Hello, good evening to everyone. Glad to see you today. In this presentation, we'll talk about our journey inside a monolith. We'll discuss how we have approached the monolith and our effort to transform it in order to embrace new opportunities. This is Yannis, our Chief Software Architect, and I'm Vassilis, Principal Engineer at Epignosis. And in our presentation, we will highlight this shift, what will bring in terms of business and also for our developers. We have heard the different voices out there, switching to microservices, returning back to the monolith, and we have set our goal to transform this product to a flexible, modular, and scalable solution. Needless to say that the product is very successful, and this monolith is the most successful product of the company. So this comes with a lot of effort, and we need to make sure that the product remains operational throughout this journey. But first, let's provide some context. Epignosis was founded back in 2012 with a vision to disrupt the e-learning industry. Through its 10-plus journey, it has grown from a small team to a mid-sized company, and from a small startup looking to pioneer in the e-learning industry to a global leader. This race continues as we try to introduce new products and also transform existing ones. The most successful product, and what we will speak today, is TalentLMS. It is an award-winning learning management system that is being used by more than 10,000 organizations worldwide, jam-packed with features, with a marketplace with more than 700 ready-made courses, a thriving LMS that is being used by 22 million users worldwide. So why are we here? If it's so successful, then why go through this process? Well, as this product disrupted the e-learning industry 10 years ago, we would like to do it again and again. Innovation was, and we believe it will be, its success for the future. Our motivation is very clear. We want to deliver even more value. We want to remove technical debt that was introduced throughout the years. We want to allow both the product and our teams to scale, and we want, in general, to modernize it. While transforming a monolith can be a complex and time-consuming task, we believe that it's worth the effort. We have seen the outcome, and we believe that continuing this is the right path. So, our journey begins a couple of years ago with a need to transform the product and, as I said, bring it to a new decade with innovation. This successful product has an impact on millions of people. It is being actively used. This successful product needs to remain operational while we modernize it. And this successful product cannot be ignored. We cannot throw it away and start from scratch. This is on the one hand. But on the other hand, this successful product is a monolith. It is hard to maintain, it's difficult to debug and modify. Again, we have introduced technical depth with Rust development, lack of refactoring, and quick fixes. It uses outdated tools, libraries, and frameworks. This creates increased compatibility and maintenance cost. It adheres to outdated practices. It's difficult to maintain, the code base is difficult to maintain. And of course, has inadequate tests. The time has come, the time is right. The journey starts by first relearning the product. We need to come again and understand what was the functionality, what its purpose. So we first began by identifying the essential components. We wanted to try to separate them, create silos of independent functionality, define the boundaries, and have a well-structured system. Pivotal role to this is documentation. We wanted to maintain transparency and consistency. To achieve this, we followed two approaches. First of all, we have behavioral-driven development, where we write down all our business rules, and then every change that is done is through RFCs, request for comments, in order to capture in the entire process both decisions and processes. We are also building a ubiquitous language. This is not only for our teams to communicate. This is used throughout the product, both inside and outside, to our customers. And now, the stage is yours, Yannis.
Thank you, Vassilis. Hello, everyone. So, Vassilis already mentioned one of the terminologies that may remind you of domain-driven design, ubiquitous languages. The main tool in that journey is DDD for us. However, going back to the presentation, as Vassilis mentioned, we had a single starting point. We had had a very successful product and a very specific need to transform it in order to innovate further. At that point, we had several paths to choose from. We went through the literature, we did all the discovery process, we read tons of documentation. We had several internal discussions. The exploration was a very fun time for us. And of course, we took account the product, the state of the code base, and several other factors. What we concluded was what we think is a domain-driven design-based approach to transform TalentLMS to a somewhat loosely called modular monolith. Vassilis already hinted that we didn't think about microservices. Our journey was straight from a legacy monolith to a modular monolith. The pattern, the modular monolith, essentially is still a monolith. It's still one single unit, self-contained. However, internally, it has a very clear separation of domains in different modules, structures, whatever you call them, communicating to each other through very clear interfaces. So essentially, we do have a services-like approach contained in one single big unit, which is still a monolith. We couldn't find, of course, we couldn't find a solution to fit all our needs. Everything was up to discussion, and we did try several different approaches at first. However, for us, for our product, this is the approach that worked, that we decided that it's going to work best. All the changes that we highlighted were very complex for us, and of course the time necessary to implement them was considerable. We did introduce one pattern that I'm going to highlight in the next slide, called the Anti-Corruption Layer. This is straight from domain-driven design. This is something that we put a lot of effort towards achieving it. It's something that a lot of us went through very specific trainings, very specific workshops to try and understand how we are going to apply those patterns to our specific code base and to our specific needs. At the end of the day, it turns out after a couple of years that it does actually work for us. Another thing that we really committed a lot of effort towards, Vassilis already mentioned that we had a very few end-to-end tests starting out. So we put considerable effort before we tried any refactoring towards upping our test coverage. That's not good. Thank you. So at this point, we have adopted a philosophy, I hope, and a culture of trying to test everything. Right. So this is more up my alley. I'm the architect. This is a diagram. This is the anti-corruption layer. On paper, it seems very, very, very simple. We have, on the one side, we have the legacy code, which is your typical monolith, several years of hard work, and of course the storage. On the other side, we have the new code, which for us mainly is a REST API, plus other stuff, and all the clients talk to the new code and the old code through this API. The anti-corruption layer, I think a better name for it, it's simply a firewall. Nothing crosses from one side to the other. The legacy code and all the practices in that side of the layer stay there. Nothing bleeds to the new side. The other side, we do try to take over time incrementally some of the, let's say, newer practices from this side and take it back to the legacy side, but that's not always possible and it's not always desirable. We have very little need to refactor the legacy code because the best definition for legacy code is code that works. So we don't really need to come back. In theory, we thought that we need to do a lot of refactoring and we need to change a lot of things in that huge code base. But in practice, over time, we found that we only need to do some small, specific surgical refactorings in some stuff. I can go into details later if you want. How the anti-corruption layer, just to make it a little bit more interesting for the engineers, is essentially a set of adapters, code that takes the old interface and tries to make it adaptable to the new interface. Inside the adapters, there are a few classes that we call translators that translate the data. That side, we also change the data. Sometimes the way we store the data in the legacy part of the equation didn't really work. So instead of going back and changing all the data, we introduced things like value objects, if anyone is familiar with domain-driven design, stuff like that, inside the layer that we call translators to make it more adaptable to the new era. And a lot of facades, that's a very well-known pattern, just to and wrappers on the older code. The biggest advantage we have from this architecture, it's modularity and maintainability. We can build our new code any way we see fit. We put a lot of effort on not changing the older code. So everything we do counts as new code, as fun code. Always a lot of, always easier to write something from scratch. But at the end of the day, because we've talked about tech, we've talked about patterns, we've talked about approaches, at the end of the day, what helped most was the transformation we did within our teams and within our people. Following the pattern, we also transformed our squads, our teams, into feature squads, following what is known as the Spotify model. And we put a lot of effort into reskilling and retraining all our people towards supporting the new architecture. I think our time is up.
Mostly, yes.
Okay. This is an ongoing effort, and we can continue the discussion in our booth for anyone interested in learning more about this, the architecture and how we adapted our teams towards it. That's about it. I think we managed to. Thank you.